Dear students, good morning to all of you. I am N. Mainaka Devi, Assistant Professor, Department of ECE, Hindustan College of Engineering and Technology. So today's class we are going to discuss about the topic is Fundamental Approach on Circuit Analysis. So these are the outlines we are going to discuss in this class. Ohm's law, Kirchhoff's current law, Kirchhoff's voltage law, nodal analysis and mesh analysis. So he is the inventor of Ohm's law, George Simon Ohm. So Ohm's law states that at a constant temperature and pressure, a current flowing through the conductor is directly proportional to the potential difference across the conductor and inversely proportional to the resistance experienced by the conductor. So he is the German scientist who experimentally determined that if the voltage across the resistor is increased, the current through the resistor will increase. So this is the statement of Ohm's law. So Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Okay. Where I is the current flow through the conductor, the unit of I is amperes, and V is the voltage across the conductor. So the unit of voltage is volts and R is the resistance. So the unit of resistance is ohms. So we can write Ohm's law I equal to V by R. So these are the example problems for Ohm's law. So first problem, a resistance of 15 ohm carries the current of 5 ampere. So calculate the voltage developed across the resistor. This is the given problem. So according to Ohm's law, I equal to V by R. So we can reframe V equal to I into R. Here we are going to calculate the voltage across the resistor, right? So V equal to I into R. I is the current value given in the problem itself. So 5 ampere. And R is the resistance. So this is also given in the problem itself. 15 ohm. So 15 into 5 is equal to 75 volt. So the unit of voltage is volt. And see the second problem. Calculate the resistance of an iron filament if it operates on 230 volt supply and draws a current equal to 2 amperes. Okay. So note that if the iron filament is a linear device, so the Ohm's law is applicable here even though it is an AC circuit. Okay. Here we are going to calculate the resistance value. So according to Ohm's law, R equal to V by I. So the voltage value and the current value given in the problem itself. So we can substitute the two values. So V equal to 230 volt and I equal to 2 amps. So which is equal to 115 ohm. The next one is the total resistance of a circuit is independent on the number of resistors in this circuit and their configurations. Okay. So series circuit. If it is a series circuit, the total resistance R total equal to R, which is equal to R1 plus R2 plus up to etc. Rn. So here N represents the number of resistors connected in the circuit. If it is a parallel circuit, the total resistance 1 divided by R total equal to 1 by R, which is equal to 1 by R1 plus 1 by R2 plus up to etc. 1 divided by Rn. The next one is Kirchhoff's current law, okay, KCL. So this law is also called as Kirchhoff's first law, Kirchhoff's point rule or Kirchhoff's junction rule, or we can call it as a node rule. Okay. So the principle of conservation of electric charge implies that at any node in an electrical circuit, the sum of current flowing into the node is equal to the sum of current flowing out of the node. Or equivalently, the algebraic sum of current in a network of conductor meeting at a point is 0. Okay. So simply we can write I plus equal to I minus. Here I plus is the sum of current entering into a node. I minus is the sum of current leaving from the node. Okay. So the current entering any junction is equal to the current leaving the junction. See this diagram. Here I1 is the leaving from the node and I4 also leaving from that node, and this I2 and I3, these two currents are entering to the node. So entering current equal to leaving current, right? So I2 plus I3 equal to I1 plus I4. This is the Kirchhoff's current law. The next one is Kirchhoff's voltage law, KVL. So this law is also called as Kirchhoff's second law or Kirchhoff's loop or mesh rule. Okay. So the directed sum of the electrical potential difference around any closed network is 0. Or we can define the algebraic sum of voltage around any closed path equal to 0. Okay. So simply we can write Kirchhoff's voltage law is V plus equal to V minus. The sum of potential rise equal to sum of potential drop. Okay. Here rise means the voltage from positive to negative means it is a drop. So negative to positive means it is a voltage rise. Okay. Let us assume this is a closed loop. So the algebraic sum of voltage around any closed path equal to 0. Here see the voltage, this is a positive one. So negative to positive. So V1 plus V2 plus V3 minus V4 equal to 0. So Kirchhoff's voltage law states that sum of voltage around any closed path equal to 0. The next one is nodal analysis. So nodal analysis is a method that provides a general procedure for analyzing the circuit using node voltage as the circuit variable. So node analysis is also called as node voltage method. Okay. For analyzing the circuit, we can use Kirchhoff's circuit's law. One can either do nodal analysis using Kirchhoff's current law or mesh analysis using Kirchhoff's voltage law. So nodal analysis writes an equation at each electrical node requiring that a branch current incident at a node must sum to 0. The next one is mesh analysis. So mesh analysis or the mesh current method is a method that is used to solve a planar circuit. So what is a planar circuit? So planar circuits are circuits that can be drawn on a plane surface with no wire crossing each other. It's a more general technique called loop analysis. So it can be applied to any circuit planar or not. So mesh analysis and loop analysis both make use of the Kirchhoff's voltage law to arrive at the set of equation guaranteed to be solvable if the circuit has a solution. The next one is potential rise and potential drop for a resistor. Okay, so potential rise. If we trace the path along a closed loop from negatively marked terminal of a resistor, then the associated potential change is called the potential rise. So simply we can write the polarity positive, negative to positive means it is a potential rise or voltage rise. The next one is potential drop. If we trace the path along the closed loop from the positive marked terminal to negative marked terminal. Okay, so positive marked terminal to the negative marked terminal, then the associated potential change is called potential drop, or we can say voltage drop. So these are the basics for circuit analysis. Okay students, thank you.